All right, everyone. So we're going to go through our waves vocabulary today. So waves vocab. Okay. And this is on page 66. All right. First thing we're going to do is set up our notebook. So we're going to separate this section into thirds. So we have the first section right here, and then the last section right here. So I'm going to take those lines and just carry them all the way across. Just like we've kind of been doing our vocabulary. Okay. All right. Now, in this top section, we're going to talk about the parts of a wave and what a wave is. So we are going to section this off. Now, I've got a little more room on the left side than the right side. So we're sectioning that off, and then we're going to split the right side in half. Over here, we're going to put waves, what a wave is. And over here, we're going to put what the crest of a wave is and what the trough of a wave is. Okay. All right. So when we talk about waves, this is what we're looking at. A wave is any sort of disturbance that happens in a solid, a liquid, or a gas. So we have the water droplet falling into water. And the moment we see that large water droplet, do you see these ripples? That is a wave. When I'm talking, this is what this would look like as sound waves through the air. Waves can move through solid, liquid, or gas, or waves can move through the vacuum of space. So there's electromagnetic waves, and these are called mechanical waves. So waves, this is a disturbance that travels through a medium. And that medium can be solid, liquid, or gas. Solid if it's something like an earthquake, liquid if it's like a water droplet moving through, even or tsunamis. I mean, tsunamis are essentially earthquakes that travel through the ocean. And then gas. Gas is air, sound waves travel through gas. And then we also have electromagnetic waves that travel through the vacuum of space. So essentially what this kind of looks like is if we had calm water, this is considered at rest. So whenever you see something that's motionless, this is at rest. If I were to drop a rock into that water would start to ripple. Okay. So what we say there is this rock disrupts the calm water. Same thing when you talk. So we have vocal cords, and these are vocal cords at rest. This would be silence. Okay. Silence, no motion, no energy traveling. Your vocal cords are not vibrating. There's no vibrations here. Once you start talking, depending on your inflection, maybe you're really, really loud, or maybe you're whispering. If you're whispering, it's really, really soft. And then the lower the pitch, the longer the wavelengths are, the higher the pitch, the shorter the wavelengths are. So this would be similar to talking. Your vocal cords inside of your throat are moving. They're vibrating, and that's what produces the sound that travels through the air. Okay. All right, let's look at the parts of a wave. Okay. Here's the crest. The crest is the very top portion of the wave. So as you have energy moving through some sort of medium, that disruption forms these kind of undulations. So we have the crest is the very top. I'm going to go ahead and show you trough. So here's our crest. It's the peak, it's the highest point, and then the trough is this lowest point down here. Okay. So that is your wave. So let's go back through here. Crest. This is the highest point. Trough is the lowest point. So I've kind of put these as if they are where they would be on a wave. So here's our wave. This is our crest up here. And then this point is our crest right here. So the tallest point, the highest point. And then our trough, this is our trough. Our trough is the lowest point. Here's the crest, and here's our trough. Okay. All right, moving it right along. You're doing amazing. So we have this middle section. We're going to make a Y to split it into thirds. Just like that. We are going to put wavelength in this box. We are going to put amplitude in this area. I guess it's not really a box, it's more of an area. And then in the bottom section, we're going to put frequency. So we have all of our wave behaviors. So this is the what a wave is, and we also have the diagram of what are the wave parts, just the basic wave parts. And then this is how waves behave. Okay, different aspects of waves. So my wavelength, this is the distance between two same points. And this is one wave to another. Okay. So let me show you wavelength. So here's my wavelength. So see how this is one point to another. You've got these red dots. And this is the other thing I need you to know about waves. Notice how these dots aren't moving in location. They're simply going up and down. And then the energy is being carried throughout the substance. So wavelength is from one dot to another, from one point to the same point. So in this example, in this video, we've got one crest to the next crest, top to top, crest, top. Okay. So wavelength. Here's our drawing. This is rest. Remember, rest is no vibration. And then this is the start. This is the end. We're going to start here. Okay. And this is from here to here. This is a wavelength. The length between waves, one wave to the second wave. Okay, so this is a wavelength. You could also do trough to trough if we had done two trough. Let's do that real quick, like right here. And we'll make it a little tinier so we could practice. So this is a wavelength. This is a wavelength. Okay, length and length. From crest to crest or trough to trough. Or you could do like, let's do it here. Down and then down right here. This, going down, going down. This is a wavelength. Two corresponding points, the same point, same location on two different waves. All right, let's talk about amplitude. Amplitude, amp, for my car people. This is how I remember this one, amp. So think about an amp, like an amplifier, like a stereo system, like amps are stereo systems. So an amp in a car. Amps are in a car. So this is crest to rest. Amplitude is crest to rest. So this is the strength technically, amplitude is the strength of a wave. So that is our definition, strength of a wave, crest to rest. Okay, think about the amp in a car, crest to rest. And then if you want A could be amplitude. Okay, here is our rest, right? So we know rest equals 0. There's nothing happening here. It is a flat line. So this is our rest. So let's put some waves in here. So amplitude is crest. So that's why we started with crest. Crest is the peak. And then here is the rest. Crest to rest. So this is amplitude. Crest to rest. This is amplitude. Okay. Moving on to frequency. Here's oh, nope, that's amplitude, my bad. So here we go. The smaller that crest to rest, so see these black lines are rest. So the smaller that crest to rest is, it has less energy, less amplitude. The more energy, the more strength, the more amplitude. Larger amplitude means more energy. Okay? More energy, more amplitude. Amplify, an amp amplifies sound. The amps in a car, the stereo system in a car, they are amplifiers. Amplify is to make louder. Bigger energy. Okay, frequency. Frequency is how the number of waves that pass in a specific time. So we have less frequency means the waves are slower. So we have the same amount of time. So here's our start time at the left, and then here's our end time at the right. And then the number of waves from start to stop is the frequency. So the frequency that you use the bathroom. How often do you use the bathroom in one class period? That's your frequency. Maybe you go 2 times in one class period. Maybe you go 16 times in one class period. The higher the number, the higher the frequency. Frequency is how often a wave occurs, or how often you do something technically. So let's go ahead and write that down. A frequency is the number of waves that pass a point in a specific amount of time. In a specific amount of time. So for example, we're going to put 2 examples at the bottom down here. Okay, this is time equals 0, and this is time equals 1 second. So let's just say that this amount of time on this x-axis is 0 to 1 second. So we're going to go crest, trough, and then we're going to end it here. So this frequency, 1 wave. Let's go ahead and do this. Let's put another crest in there. 2 waves. Okay, so there are 2 waves. The frequency here is 2 waves. One more time. Time equals 0. Time equals 1 second. Let's do shorter waves. Okay, so we have crest to crest, 1. Crest to crest, 2. Do you see what I'm doing? Let me zoom you in. We have crest to crest. This is a wavelength, 3. Crest to crest, wavelength 4. Crest to crest, wavelength 5. Crest to crest, wavelength 6. Crest to crest, wavelength 7. Okay, so there are 7 waves here, while there are only 2 waves here. So this frequency, this is a higher frequency. This is a lower frequency. Almost there, y'all. You're doing so phenomenal. Hopefully. Okay. Our last area here, we're going to keep this all the same, and we're going to just talk about the types of waves. Okay. There are two major types of waves that we're going to break down. We have transverse waves, and we have longitudinal. Okay. Transverse and longitudinal. So transverse waves, let me show you these before we kind of define these. Here's my types of waves. Longitudinal, they're long. See how it's a long line? Long, length. It goes lengthwise. So longitudinal waves, and then we have transverse waves. Transverse waves are tall waves. Transverse, tall. Longitude is long, length. Okay. Longitudinal waves are called compression waves. If you push the slinky, they're compression. So some things that compress together and then move forward. So these are longitudinal waves are compression waves. And then transverse waves, they disrupt things going up and down. Okay, so transverse. Transverse waves. Up, down. Okay. Examples of transverse waves are a string. If you had a string and you like flick the string like this, so like that, that would be a transverse wave. Water ripples. These are transverse waves. Longitudinal waves, watch how I'm going to draw this carefully. They are slinkies. So think of a slinky. A slinky is essentially like that long coil of metal. So the further apart the coils, the longer the compression, the closer together the coils. So this is a wavelength from compression to compression, and then this is a wavelength from a little bit more expanded. Wavelength here, wavelength here. So that is a longitudinal wave. That is a compression wave. So we could put compression. If you compress something, you push it. They're push waves. Some places in earthquakes, they'll call these P waves. Push waves, compression waves. All right, my friends, you have done such a lovely job finishing your vocabulary today. Your next step is to log back into Canvas and go ahead and complete that vocabulary practice quiz. Thank you so much.